There's a trolley on the table. Push the trolley and it reaches a certain speed very quickly. But after the trolley has moved forward a short distance, it stops. The deceleration of the trolley shows that there's force acting on the trolley. When the trolley glides over the table, a force is acting between the trolley and the table. This force is known as friction. The friction between objects can reduce the speed of the objects. Use a Newton balance to pull a wooden block on the table. Although the speed remains unchanged, the pointer of the Newton balance shows that force is required to pull the block. As there's friction between the wooden block and the table in a direction opposite to the direction of motion, force is required to pull the wooden block if we wish to keep the block moving at a constant speed. When a space shuttle returns from space exploration and enters the Earth's atmosphere at a great speed, the friction between air and the space shuttle is very high. The high friction creates a huge amount of heat. The outer hull of the space shuttle is covered with heat-resistant tiles to prevent the space shuttle from burning at the high temperatures. A trolley can move on a linear air track because a blower blows out air from small holes on the track to form a layer of air. The layer of air reduces the friction between the trolley and the track so that the trolley can glide along in a state of virtually nil resistance. Fix an air-filled balloon on top of a round disc. Release the balloon and slightly push the disc. The disc glides away easily. The disc can glide because the air released by the balloon forms a layer of air between the disc and the table, reducing friction. When the air in the balloon is gradually exhausted, the layer of air disappears and the friction increases. The friction stops the disc. A hovercraft operates on the same principle. A cushion of air is formed between the hovercraft and the water surface to reduce the friction between the two, so that the hovercraft can move with great speed in the sea. A jetfoil operates on the principle of hydrodynamics. When the jetfoil reaches a certain speed, the body of the boat rises from the water surface and travels quickly. By gliding over water, the friction between the boat and the water can be reduced so that the jetfoil can reach a great speed. A magnetic levitated train operates on the principles that like poles repel and unlike poles attract. The train body is suspended above the rail by magnetic force, so that there's no physical contact between the train rail and the train. Then the interaction between the magnetic field of the track and the magnet on the train pushes the train forwards. As the train's uplifted from the track by magnetic force, the friction between the train and the track can be reduced, making it possible for the speed of the train to exceed 500 kilometers per hour. In the skating rink, figure skaters dash and spin gracefully on ice. Figure skaters can glide over ice because the friction between the skates and the ice surface is reduced. There's a piece of metal at the base of the skate. When the skate dancer glides over the ice in contact with the piece of metal melts under pressure and forms a layer of water between the metal and the ice. The friction between the skates and the ice is thus reduced. Friction is closely related to the shape of an object. Oceanic mammals have streamlined bodies. When they swim quickly underwater, the streamlined bodies can help to reduce friction. Various means of transportation, such as airplanes, fast trains, race cars, and racing boats, have streamlined designs in order to reduce air friction. There's friction between the turning wheels and gears of a machine. This affects the performance of the machine. Apply some lubricant between the gears. This helps reduce friction and allows smooth operation of the machine. Sometimes friction helps. When it rains heavily, cars running on the road skid easily. For cars to run steadily on the road, there has to be friction between the road surface and the wheels of the cars. The grooves of the wheels increase the friction between the wheels and the wet road surface. An anti-skidding paving surface on a slope also helps increase road safety. There are anti-skidding surfaces on some pedestrian walkways. Rubber surfaces and grooves help increase the friction between the road surface and the soles of the pedestrian, so that it's less likely that the pedestrian skid on the road, particularly when the surface is wet. When we want to stop a moving car, we have to activate the braking system, so that friction helps to reduce the speed of the car.